Hello everyone, welcome to this channel. So today we would be simulating a common drain amplifier using LTspice tools. So before going into the simulation of a common drain amplifier, so let us understand about the common drain amplifier. So common drain amplifier is also known as the source follower circuit, and it is depicted in the figure which is shown here. So a source follower typically used as a voltage buffer. So the gate terminal of the transistor serve as an input and the source is the output, and the drain is common for both input and the output. So if we use a current source for a load with a large small signal output resistance, the gain goes to 1. The gain is the voltage divider between the resistance looking into the source of MOSFET and the output resistance of the current source. The maximum current the NMOS source follower can sink is limited by the size of current flowing in the current source load of M1. Source follower is a class A amplifier where when discharging a load capacitance, the current through M1 limits to the rate at which the capacitance can discharge. When the source follower is sourcing a current, M2 provides the current to both the amplifier output and to the M1. Thus, M2 only sources the current and M1 only sinks the current. When the source follower is sinking the current in M2 decreases while the current in M1 is constant. The maximum output voltage of an NMOS source follower occur when the gate of M2 goes to VDD. So you can see that gain is given as V out by V in, and it is nothing but the resistance connected to the source divided by resistance connected to the source plus resistance looking into the source. Now let us start simulating the common drain amplifier using the LTspice simulation tool. So first click on this new schematic, and a new schematic window opens. So go to component section. Now in this common drain amplifier we require the NMOS based transistor. So we would be selecting N-channel MOSFET transistor with explicit substrate connection. Okay, so place 2 NMOS transistor, click escape. Now in this example we would be using the BSIM4 based model. Okay, ensure that this particular BSIM4 based model is present in this particular file where you would be where you would be saving that circuit. So when we open this BSIM model, you can note that this is the model name N_1 micro. Okay, so we have to use the same model name if we are using this BSIM model. Okay, so and also ensure that this particular BSIM model is present in the folder where you are saving this circuit. So now right click and change this model name as n_1 micro. Define the length of first transistor as 1 micro and width as 50 micro. Click OK. Similarly, for the second transistor, save the model name as n_1 micro, the length as 1 micro and the width as 10 micro. Click OK. So we have the two set of transistor. Now we have to define V input and V bias for the common drain amplifier, and also we require VDD and VSS. So we would define this in the form of a pen. So go to labelnet, define VDD, which is an input. Click OK. Place this and escape. Now again go to labelnet, define this as VSS, input, click OK, place this, escape. Click on labelnet, define this as Vin, input, OK, escape, labelnet, V bias, input, and in the end labelnet V out. Click this as output. Okay. Now click on wire, connect all the wires. Now connect the substrate connections. So we are done with all the connections. Now the very important aspect in this is, since we are using the BSIM4 model, we have to include this particular BSIM4 model in our schematic. So go to edit, click on spice derivative, and you have to type this following command: dot include bsim4 underscore models dot text. Click OK and place this. You can see that this particular model bsim4 underscore models must be included in our schematic here. Okay, so we have completed this particular schematic. Now we have to convert this into a symbol. Now save this particular schematic. So go to file, save as, and now let us give this name as CDA. Save. So we have saved this particular schematic. Now we have to convert the schematic into a symbol. So go to hierarchy, and click on create symbol. Now click on draw line and create a triangle. So we would define that as a common drain amplifier symbol. Now click escape. Now we have to define 4 inputs and 1 output. So you remember we had defined V in, V bias, VDD, VSS and V out. So go to edit, click on add an pin port, define label as V in, similarly define for V bias, edit, add pin port, V out, go to edit, again add pin port, VDD, and go to edit, add pin port, VSS. Okay, I missed the label, VSS. Okay, so we have defined all the pin. Now we have to make the connection using the line. Join this, draw line, escape, draw line, now let us name this as common drain amplifier, that is like CDA, and place this. Okay, just to make things convenient for us. So now we have to save this particular symbol. Okay, so go to file, click on save as. Now this is very important. So you can see this folder called as my symbols. So what I did is that since we are creating our own set of symbols, so in the LTspice library there is a section called as symbol. So I have created my own folder called as my symbols. So double click on that. Now save this symbol as CDA. Okay, save. So we are done with the creation of a symbol for the common drain amplifier. Now the next is simulation. Okay, so let us do that. So next, again click on new schematic. Okay, so now click on components, my symbols. So click on common drain amplifier, that is CDA, which is a symbol which we had created. Click OK. and place this symbol. Escape. Now we have to define various voltage sources, that is for VDD, VSS, Vin and Vbias. So we will click on component and select this particular voltage source. Click OK. So now we have 4 different voltage source. So let us name this accordingly, I mean to make things easier for us. Let this make as VDD, okay, this as VSS, the value of VDD as 2.5 volts, VSS as minus 2.5 volts, okay, and let us make the value of V bias as 2.5 volts. Now use a wire, connect this to VDD, connect this to VSS, V4 to V bias, and we require ground connections, okay. Connect all the ground connections. Next, we have to define this V input, okay. So first let us change this to V in. Right click, go to advanced, sine, DC offset as 0 volt, amplitude as 5 millivolt and frequency as 1 kilohertz. Click OK. Now make the connections to Vn and then to the ground. So now we have defined, so we have done all the connections. Now first thing is that you have to include the BSIM model file, okay. So similarly dot include BSIM 4 underscore models dot text, okay. So save this and place this. So now since we have completed the common drain amplifier circuit, so what we will do is that we'll try to analyze the DC analysis of the common drain amplifier, okay. So now the important factor is that this particular BSIM model file, if you don't include this BSIM model file, then you will end up getting an error, okay. And also ensure that this particular BSIM model file is present in this particular folder where we have saved this common drain amplifier schematic and the common drain amplifier circuit, this one, okay. Now let us perform the DC analysis of the common drain amplifier. So go to edit and click on spice analysis. Now we have to do the DC sweep. So the name of first source to sweep will be Vin, and the type of sweep has to be linear. Let us consider the start value from minus 2.55 volts. Start value as stop value as 2.5 volts, and the increment has to be 0.1 volt. Okay, now click on run. Now click on this Vin and click on V out. So you can see the DC analysis of the common drain amplifier. I hope this was a good learning experience for you. Thank you for watching this tutorial. I request you to subscribe to my channel below. Thank you.